Hello, everyone. Today, I want to give an update to the project that is a little different from the regular RL lecture series. Recall that recently we formed a small team to revise and expand my Q-Learning survey paper. Instead of teaching one specific RL algorithm, the video is about why we are building this project, how it started, and what we hope to learn from it. And this original survey started as my personal project. I wanted to organize decades of Q-learning research from classic Q-learning and DQN to more modern value-based methods. The paper was submitted to IEEE Transactions on Artificial Intelligence and received a major revision. The reviewers recognized the coverage, but they also wanted deeper analysis, stronger synthesis, and more modern RL discussion. So instead of treating reviewer feedback as only criticism, we decided to treat it as the starting point for a better project. And one important shift is how we organize Q-learning. A simple survey can list algorithms, DQN, double DQN, PER, rainbow, and so on. But a stronger survey should ask what problem was each method trying to solve. For example, double DQN addresses overestimation bias, PER addresses sample inefficiency, offline IO addresses distribution shift, multi-agent Q-learning addresses coordination and credit assignment. So the goal is to move from a list of papers to a map of problems, solutions, trade-offs, and open questions. And now let me show a diagram. So the diagram on the right-hand side, basically this is the traditional Q-learning method. So we can see there's the target stabilization, smart exploration, distribution paradigm, and the data efficiency such as replay, and also architectures and integrative approaches. On the left-hand side, we see the modern domains such as multi-agent Q-learning, Q-learning for large language model, Q-learning for continuous control, and also empirical benchmarks such as DeepMind's B-Suite, some more Atari, or even LLM problem, or even robotic manipulation tasks such as Q-learning on continuous control. The current team consists of 7 contributors, and some people are research focused, while others are more engineering focused. This is actually useful because the project needs both. A survey paper needs careful reading and synthesis, but it also benefits from code, experiments, repository checking, and reproducibility analysis. The goal is not for everyone to already be an IL expert, the goal is to learn together and contribute from different angles. So what are we actually doing? We divided the project into 3 main tracks. The first track is to recategorize Q-learning methods. This is about improving the taxonomy and making the paper more analytical. The second track is modern Q-learning. This includes offline IL, multi-agent IL, Q-learning for large language models, and also continuous control. And finally, the third track is benchmark analysis beyond Atari. Atari is historically important, but modern IL needs broader evaluation. Together, these 3 tracks directly respond to the reviewer feedback. And one important ground rule for the project is AI can help, but humans must verify. AI tools may help us organize ideas, summarize papers, or brainstorming structures. But for a survey paper, trust is everything. Any factual statement that enters the manuscript should be traceable to an actual paper that at least one contributor has read. And generated content could be messy, verified content is valuable. And finally, what success may look like. The goal is not only publication. Of course, we hope to revise the paper and eventually publish it, but the deeper goal is to learn reinforcement learning, write some code, build something together, and create a useful resource. If the project helps people understand RL better and apply it to their own domains, this is already meaningful. Publication is the destination, learning is the actual journey. Thanks for watching, and I will share more updates as the project continues.